All right, so this is lecture 2 of how to balance the impossible. So let's go ahead and remind you of where we left off with this nice little 5-step reaction showing the oxidation half reaction. Okay, so we had to go through 1 through 5 twice, and then step 6 is what we call cross multiplying. And when you do your problems, you will be asked to rewrite the final reaction for the reduction and the oxidation. Make sure you label those. You can use red and ox if you want. This is the reduction, and this is the oxidation. So one of the things you'll note about this, these two are going to combine to form one reaction because this whole thing is an exchange and a redox reaction. But you can't have this happen because this guy gained 3 electrons, and this guy lost 2 electrons. That's impossible. So this is what we talk about a cross multiply. And I want you to show your work on this. So you take this whole thing, use brackets, because we're already using parentheses in the formulas and whatnot. So you put brackets around the outside, multiply the whole shooting match by 2. That means you will have gained 6 electrons, and then you multiply this one by 3 so that you lose 6 electrons. And then you've got that nice balance between the two of them. Okay, so now you have rewritten so that we can stack them right on top of each other, and this is a new step. So you're going to say step 7 when you're doing your problem. You're going to write the revised oxidation and the revised redox reaction or reduction reaction. So there's the reduction, there's the oxidation, and oftentimes there'll be more than just the electrons that will cancel out, but in this case, boom, 6 electrons cancel out. You have the reduction and oxidation, the gain and loss of electrons is equal. So now you have the final balanced chemical reaction. That would be very difficult to predict those coefficients without going through those steps. But one of the things I like about this even more than regular balancing is that you can analyze this and go step by step in a very logical manner. So that's the final answer now. It took you quite a bit to get to that, but you're going to get a chance to practice some of these. Again, that would be tomorrow on a work day. This is just notes today, just as a reminder, so don't start the problems yet. There's some specific instructions, and I just want to make sure that you're clear on how to do that. We kind of already talked what happens with nitrate. And this is one of those things where, how do you know NO3 goes to NO? You just do. You just know it, like you know what your first name is. You just learn it, and most of you have got your names down really well. And this is just one more thing you need to learn. It's like learning Spanish. You have to learn a new terminology and a new thing. So what does permanganate do? Well, permanganate goes from MnO4 to a positive 2 ion. That is if it's acidic. We're going to talk about next week. In a basic solution, that's a different reaction. Dichromate is one you'll see. And again, commit this to memory. There are some logic that may help you kind of justify this. But honestly, I think it's just easiest to sort of say, I know what dichromate is, and I know what it turns into in terms of the oxidation number. And of course, all these oxidation numbers are going up, which means these are the oxidation. These are common reductions of getting this thing started. Okay, so these are common reductions. So you don't want to look at the total charges. You want to look at the nitrogen itself going down in oxidation. Sorry, screwed that up for you. So here, manganese goes from +7 down to +2. So these are reduction reactions, and you just want to kind of commit these to memory. Those are three really common ones. And what if you have these sulfite ions? It will oxidize into sulfate, and you notice here that the oxidation number is going up. You got your jumping lion, so that is a oxidation. So this one could be coupled with one of the three that we talked about on there. This is kind of a tricky one. Peroxide is oxidation. Notice this goes from -1. That's the exception. It's the one rare case where oxygen is not -2, and it's going to be 0 over there. That's actually up, which is, again, an example of an oxidation. So if you see peroxide in there, you go, oh, that's going to be the H2O2 going to oxygen. Again, that doesn't make logical sense in terms of trying to balance it, because we're going to add the hydrogens in a different format. Here's another example. C2O4 -2 will undergo a change and become CO2. So you'll recognize that. Let's check out the oxidation numbers on these guys. The oxygen doesn't change. The carbon here, let's see, that's -8, so you'll need +3. And then that goes to a +4. So this is an oxidation, to raise its oxidation state. All right, and changes up to a +4. Okay, so that's all explained in that layout right there too. And if you're talking about chlorine going to Cl2, chloride ion to Cl2, that's -1 to 0. Again, that's up, so that's an oxidation, as we mentioned before. Now, if you have a metal with the chlorine, then it's the metal that will be oxidized. So here, the chlorine by itself is oxidized, but if you combine it with a metal, the metal will oxidize. And tin, this is just one, it's 2 and 4. Lots of stuff to kind of, just commit into your melon there. Okay, so at this point, we're going to stop, and then we'll just do 1 or 2 more of these problems. But it's really, this will help you with the first step of these problems, is knowing and having these memorized, or certainly with the assignment, knowing where to look these up, these common examples of reduction and oxidation. And then when you see them in word form, like is coming up on this next problem, then you will know what to do, and you'll know how to do that. So before we start the next video, see if you can take a look at this one and see how it relates to what we did leading up to this. Could you tell me when we do step 1, what is the reduction reaction and what is the oxidation reaction given this? Okay, so see if you can think that through before we start the next video, and that's how we'll start the third video, is by just kind of quickly going through. Now you kind of know the steps, and we'll set that up, we'll go through it, and we'll get that balanced. Like I said, these problems are pretty involved, so you're just gonna learn it today, and we'll practice it tomorrow. So, end of video 2. Moving on to video 3.